Okay, I asked you to do this for homework um, from your in-class day. So it says express the following numbers in proper scientific notation. Maintain the same number of significant digits. Okay, so scientific notation means you need to move the decimal so that the number in front is between 1 and 9. So this is going to become 1.20652 times 10 to the, and then you need to count how many places you moved it. 1, 2, 3, 4, 5. Moving it to the left, positive, or because it's a big number, the exponent's going to be positive. Numbers between 1 and 9 in the front of the decimal kept the same number as sig figs. Okay? Next one, we need to move the decimal in the opposite direction so that it'll become 5.26. There's only 3 significant digits here because the leading zeros do not count. So 5.26 times 10 to the 1, 2, 3. We've moved it 3 spots, but in the opposite direction. We've moved it to the right. The number's tiny, and so then the exponent's going to be a negative. Next one, we only have to move it one place, right there. So 8.7. Now, what digits stay? Have to keep the same number as sig figs. The front zero isn't significant, but these 3 are. And so the in 3 along with the 8.7. So 5 significant digits. So 8.7020 times 10 to the, moving it to the right again, just one spot, -1. This guy, moving it to the left, 2 spots, so it'll be 5.000, because all those digits are significant because there was a decimal there, times 10 to the 3. 400. Only one sig fig. So 4 times 10, and we have to move it 2 places. To the 2, going to the left, 400 is a bigger number. It's not a decimal. It's going to be positive. Now this last one might cause confusion because it might look like it's in scientific notation, but it's not in proper scientific notation because 32 is not between 1 and 9. So you need to move the decimal one more spot. So it's going to be 3.28 times 10 to the, and when we move it that way, the exponent goes up, so it'll be times 10 to the 4th. Okay, so that's the top piece. The bottom piece wants you to do the opposite. Wants you to write it out in longhand. Okay, so instead of 2.998 times 10 to the 8th, it wants you to write it out as 29980,000. Right? 1, 2, 3, 4, 5, 6, 7. I think I lost a decimal, or lost a spot. So much for me trying to write it. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I just now, because of, okay, let me fix it, because that's going to bother me. Is it going to bother you too? Always plan ahead. 2.99800,000. Now it's in the correct form. It was before, it just didn't have groups of 3 in the right spot. Okay, so we moved it 8 this way because it's a positive exponent, which means it's going to be a big number. This one's a negative exponent, which means it's going to be a small number. So it's going to be 0 point, and it's -4, so we need to move it 4 spaces, which means there's going to be 3 zeros, a 5, a 0, a 0, and a 2. Right? So it was here, 1, 2, 3, 4. Yep. All right, the next one is also negative, but it's just a -2. So it's going to be 0.06410. Okay, 4 sig figs, 4 sig figs, 4 sig figs, 4, 4, 4. So we've kept the right number of significant digits. All right, this one is a +4, which means I need to move the decimal in the opposite direction to make it a big number. So it's going to be 96425. I've just moved it 4 places. 1, 2, 3, 4. Yep. And then this guy, 5 spots, and it's positive, so 8, 0, 0, 0, 0, 0, 3, 4, 5. But there's a problem with this one. Here it has 3 sig figs, but there's no way I can write it out longhand and still get 3 sig figs. So this is what it's equal to in longhand, but the number of significant digits is not correct, okay? Which is why we use scientific notation. So that was your homework. The other side of the sheet, this was part of your homework too, but I said I was going to get you to pass it in the next day you're back. And you could do it right here on the sheet. Excuse me. So, and I leave you a space for to put in the conversion factor. So the first one, I want you to change 3.27 centimeters to something in meters. So you could do right here 3.27 centimeters, and you're going to multiply it by some factor to give you this. If you want to end up with meters, it goes on the top, centimeters will go on the bottom. Always put a 1 on the bigger one. 100 centimeters in a meter. Now the centimeters will cancel, and so you're going to divide this by 100. And then you're going to write your answer right here. Excuse me, I got a tickle. All right. And so you can use your chart if you don't remember what these things are. But notice down here there's some kilometers per hour and meters per second. And we didn't have a chance to talk about those. So let's go back and talk about those for a minute. So let's suppose I want to change 90 kilometers per hour into something that's meters per second. Okay? So I need a conversion factor that's going to change kilometers into meters. If I want to get rid of the kilometers, I'm going to put it on the top. And if I want to end up at meters, if I want to get rid of kilometers, I'm going to put it on the bottom. If I want to end up with meters, I'm going to put it on the top. But I also have hours that I want to get rid of. And right now, the hours is on the bottom. So in the conversion factor, it needs to go on the top, so it'll cancel. And seconds needs to go on the bottom, because that's where I want to end it, and want the seconds to end up being. So then remember, you always put 1 on the thing that's bigger. How many meters in a kilometer? 1,000. And then you're going to do the same with the hours and seconds. Hours is bigger. How many seconds in an hour? Please don't say 60. It's 60 times 60, right? 60 seconds in a minute, 60 minutes in an hour. So 3,600 seconds. So then you would multiply 90 by 1,000 by 1. And then you would divide by 3,600. Kilometers will cancel. Hours will cancel, and when you do this, you should get 25 meters per second. Okay, let's go the other way maybe. Let's do 30 meters per second, and I want you to change it to something in kilometers per hour. So meters are on the top. We want to cancel them out, so it needs to go on the bottom. And we want to be left with kilometers. Seconds is on the bottom, so to cancel out, they have to be on the top, and we want to be left with hours on the bottom this time. Put a 1 on the bigger, which is kilometers. There's 1,000 meters in a kilometer. In the hour-second one, put a 1 on hours because it's bigger. There's 3,600 seconds in an hour. Multiply 30 by 1 by 3,600. Divide by 1,000, or 1,000 times 1, which is 1,000, and you should get 108 kilometers per hour. Okay, so that's how you do the kilometers per hour one. So on the sheet that I'm asking you to do, there's 1, 2, 3, 4, 5, 6 of them for you to try here. Note this ml is mega liters, okay? It's a capital M. All right, so that was your work from yesterday. In the next video, we'll look at new stuff.